All right. We are set and ready to get started. Will
All
you
right.
be sharing your screen?
Yeah, let me share my screen.
Alrighty. Let's get
Yeah,
started.
sure. Thank you, Chibi. So, hi everyone. Welcome back to the public deep dive on the technical side. My name is Raymond, CTO and a co-founder at a Bridge. We're building Collab.Land and the Telefriends. So today we talk about the smart car migration slash upgrade. So most of you probably know, like nowadays, when it comes to wallet, we have a lot of different choices. Typically, people will have wallet coming from the different wallet providers, such as the MetaMask, Wallet Connect, and whichever favorite wallet provider you use. And this wallet are typically called EOA, which is controlled by a private key or seed phrase. And you kind of take the whole responsibility to manage this wallet. Uh, then afterward, like people realize the EOA wallet is not very user friendly. It does not have the ability to be flexible and support different features such as the recovery, multiple owners. Then the smart car idea come into the picture, which is the ERC 4337. It's a continuous innovation on top of the smart contract based wallet. And finally, we have this standardized approach that pushes the boundary of user engagement and give the user a lot of flexibility to use their wallet in the blockchain. So uh, at the beginning, you kind of start with some EOA wallet, and then you start to deploy the smart contract onto different blockchains. And this smart contract based wallet becomes your smart account. Then, of course, you can control the smart account from an EOA as a signer. Then, over time, the implementation logic of the smart contract becomes even better and better, especially with the emergencies of the modular account called ERC 6900. So basically, there's going to be a lot of different plugins behind your smart account that deal with a different perspective of your smart account and provide different capabilities, such as the multi-sig, signature control, security recovery, um, and some other fancy ways to manage your smart account. So the smart account sort of becomes your set of user-facing entry point that fully leverage the capability of the ERC 6337. And you can also get the benefits such as the paymaster. So the gas payment sometimes becomes so much a headache for a lot of users, right? And it creates a heavy chicken and egg issue. But with a smart account, of course, you can get sponsorship from a third party to pay the gas, or you can actually use your ERC20 token as a payment method to cover the gas fee. Uh, so those are kind of the benefits of the smart account, but of course, smart account comes at some price, right? So first of all, you will get a separate smart account on different blockchain networks, which is different. You get the same EOA across different blockchains. Okay? And the smart contract itself is backed by a smart contract. So that's why you probably will have different choices to choose different providers. It's becoming even tricky, like say, you have to upgrade your smart account by adding a new owner, remove the old owner, or you actually even switch to a newer version of the smart account implementation to get more functionality, or you actually complete move away from one vendor to another one, right? So that's a challenge we are facing today. When we provision the smart cards for our users at different phases, they might get different implementations, and also when we evolve the user onboarding insurance, the signer for your smart card can change over time as well. Maybe at the beginning, you use EOA as a signer, but then when we onboard the user with the MPC wallet, this intelligent, EOA will kind of help you to drive the adoption of smart card and control the signing of the smart card itself. So we're doing some POC to exercise this smoothness upgrade for your existing smart card, right? So that comes from two angles. One is you want to add a new owner, remove an owner. So that's kind of a management, not directly an upgrade or migration, right? So that's number one. Number two is when we adopt different ERC 4337 providers, and especially when the standard around the modular design of the smart card evolves, we might have the need to swap up the implementation for your smart card without, jeopardizing your assets that's already been stored for your smart card. Right. So one concrete use case for us is initially we use Bioeconomy smart card as the default implementation. And of course, like the Bioeconomy smart card has a modular design that fits our need at that point. But the Bioeconomy modular design is still a private implementation. And then now there's a public standard being pushing forward, which is ERC 6900. And it's a plugin-based extensibility for the smart card and kind of allow the user to opt into different modules to give different capabilities of your smart card. And Alchemy is a front runner of doing that. So recently they just launched modular card infrastructure, and we decided to create some POC so that we can meaningfully help our existing users with the existing smart cards to have the possibility to upgrade the smart card to be the ERC 6900 compatible smart card, right? So that kind of imposed some challenges because it's the smart card, whenever it's being deployed, right? So you cannot really mutate the smart card itself. But the good news is the smart card being deployed for our users is actually using the proxy pattern. That means you have two parts of the smart contract. One part is this proxy that represent the state for the smart card itself. Then you actually not have any business logic in the proxy. You kind of have a pointer to an implementation contract. So the implementation contract is being deployed by the ERC for system providers like Bioeconomy or Alchemy. But the contract itself does not maintain its own state. It's basically read and write the state from your smart card deployment itself. Then combining the power of this proxy and the implementation, you have this decoupling between the two, which give us this possibility to swap up the implementation. Another good news is the implementation from Bioeconomy or Alchemy, they start to use this, modular design. That means some of the states, it's not directly storing here or here. It's actually storing into some registry smart contract. For example, for Bioeconomy, when you provision the smart card, right? So you need to have a signer for that smart card so you can meaningfully sign transactions or message on behalf of the smart card. Because the smart card itself does not have the signing capability, right? But it does have the verification capability. So that's why typically you kind of start with an EOA or MPC wallet. In our case, it's the PKP from the LET protocol, which can be nominal function like signer, but toward the end, its primary responsibility is to sign, right? So for the Bioeconomy case, when you initially provision a smart contract, you have the owner address, which could be your EOA or the PKP address. So the state is being set into another smart contract called ECDCA, ownership validation module. And actually behind the scenes, it's actually use your smart contract address as a key to map to the signer. So kind of maintain some state in this smart contract. So that's another piece of good news. Now we decide to migrate a smart contract from your bioeconomy infrastructure, the bioeconomy implementation contract, to Alchemy, modular contract implementation. How do we do that? So the couple steps involved, because first of all, this is a proxy, right? So we can actually use a proxy to call some methods to repoint the smart account from bioeconomy to Alchemy implementation contract. So that's where this update implementation method come into play. So that's part of the smart account proxy we got from bioeconomy to allow us to upgrade the smart account. But initially, that's designed to upgrade from version 1 to version 2 to version 3 or whatever. But we are able to leverage this hook to completely swap up the implementation. So that's the first step, right? But you cannot directly just call this method and be done with it, because if you just only call this method to have your original signer to sign that transaction, sure, your proxy will point to a new implementation, but you don't have any state if you only do that. Remember, for the initial setup, your state is being stored here, so that the smart contract to manage your smart account from bioeconomy understand who's the authorized signer and what signature should be respected, right? So it kind of reach out to this module to say, oh, for my smart contract address, here's the signer address. And then whenever the signature matches the signer, we authorize that user operation to go through, right? But now if you break this tie, and the old state will be lost, right? Then how do we make sure we still have functional smart contract? So that's a second step coming into play, because typically when you upgrade the new implementation, and the new implementation offers a method called initialize. So the initialize is kind of like a little bit like the constructor for your smart contract that gives you that one-time chance to set up new states or reset the state or the proxy itself. So that's where this new setup coming. So for Alchemy implementation, since it's based on ERC 6900, so it basically have a way to register a plugin. And this time around, we're going to use the so-called multi-owner plugin. So any signer addresses get added to this multi-owner plugin. It has the ability to control this smart account. And of course, you can have multiple owners to be registered, and that will have the equal right. So this gives us some good flexibility, especially when you try to migrate the signer altogether, right? So you can keep the old signer, you can add a new signer into this multi-owner plugin, right? Then of course the Alchemy, multi-account will have a hook. So this hook will apply some state change to this smart account. So that means like we can actually achieve this migration from one vendor to another one in 2 steps. And how do we make sure these 2 steps happening within a atomic transaction, right? So that either both are successful or both, just don't create any side effect, right? So that's the beauty of the smart account, because now you have the smart account, so we can build a user operation. And that user operation can encapsulate multiple steps as separate transactions within that user operation. For example, number 1 is we have this update implementation. Number 2 is we have initialize. Then you can continuously piggyback these operations into a user operation. For example, the user not only just upgrade their smart account, but also want to do a ERC20 transfer to send some ERC20 tokens from the smart account to another address, right? So these three steps can be bundled into one user operation. Then we can submit that user operation, which is signed by the original owner for the smart account coming from Biconomy. And of course, once we finish that user operation, the owner will be registered on the Alchemy implementation. So that kind of keep everything smooth and transparent, right? So that's kind of the tricks we are doing to enable this smooth upgrade from one existing implementation to another one. So let me quickly go to the code and showing the script how we do that. So that gives you some concrete ideas what's happening behind the scenes. So I wrote this simple utility to test the whole path. So basically, we try to have a Biconomy, a smart account, and then afterward, we migrate or upgrade that to be the Alchemy modular account, right? So the interesting part is, I kind of doing everything from ground up. So first of all, I create a smart account from Biconomy, and then we have this smart account address, right? Then we try to do a ERC20 token transfer. So we first transfer some ERC test token into the smart account so that smart account have some balance. Then afterward, we say, okay, let's try to upgrade the implementation from Biconomy into Alchemy. So the meaningful part here is we work with the Alchemy team to create this help method, and this help method will create a transaction for a user operation. But for a transaction to be useful inside the user operation, we sort of have to encode that transaction to be a core data. Right? So that's where we pass in the new owners for that smart account. But in this case, we keep the owner as the only owner, but you can add more owners here to control the new smart account. We keep the same address for the smart account. The second step is we create a update implementation transaction. So again, this is a method call on the Biconomy smart contract for the proxy part, right? And we say, okay, what is the new implementation? So this implementation address now points to the Alchemy smart contract, right? Then this user operation bundle, it's representing the different steps. So as you can tell in this array, we have a few different operations. Number one, we make a update implementation call on the proxy contract itself. And the proxy contract address is actually the same as your smart account address. Sometimes we call that sender address, right? So this step basically say, hey, let's call update implementation against the proxy contract for your smart account. And this code data already encapsulate the function name as well as the argument, which is the implementation address for Alchemy, right? So that's the first step. Second step, I say, hey, right after that, we need to initialize the smart account with Alchemy setup, right? So that's where the second step comes in because we already built this initialization data for the modular account. Again, this transaction will only happen on the proxy itself as well. So this step actually restore the state, especially the ownership of the smart account using a new implementation. Then I also have a user operation, which is say, okay, let's try to transfer some ERC20 tokens from my smart account to this recipient address. And of course, I made a mistake here. So I actually have two transfers in a row. So you will end up seeing we are transferring the ERC20 token twice with this amount, right? Then, as I said at the beginning, because it's a small account, so potentially you can involve the paymaster to pay the gas for you. So we enable this sponsored mode so that or paymaster will cover this gas. And I just did a run before this session. So basically, we call this script and say, okay, let's first create a bi-column smart account with this address, and of course, the initial balance for that smart account is 0 for my ERC test token, right? Then we give this smart account with some new balance. So here's a new balance for that ERC20 token. So now the bi-column smart account have some initial balance. So I just want to upgrade the smart account into Alchemy right away. So we submit this user operation to the testnet, and I'm going to copy the user operation hash. Then of course, once we finish the user operation, we get a final balance of the smart account because we transferred some token out. So we lost like a unit of 2 here, right? So the final verification is we started call some method on the new smart account, which points to the bi-column infrastructure. So this gave us some pointer to the plugin infrastructure. So this is the contract address for the multi-owner plugin. So this verified the migration or upgrade was successful. So let's switch gear again because I want to show that user operation. Right? So I already copied the user operation hash here, and we have this nice UI called jeffyscan.xyz, right? Then you can tell, okay, we perform this user operation, and here's a paymaster actually help us to pay the transaction. Then toward the end, we have 2 ERC20 transfers. So we transfer the balance from this smart account to this EOA wallet for this amount of like test tokens twice, because my code asks them to do the transaction twice, right? Then you can get a lot of information from here. Like you say, you can look at the user operation logs, but this is a little tricky because they don't recognize all the different events. So that's why I kind of switched to the traditional transaction explorer for, so I click on here, then it will launch the Arbitrum transaction hash on the testnet, right? So what's interesting is you should look at the logs. So if you look at the logs, the initial events is talking about the setup, the bi-column smart account, right? So you kind of have the proxy fallback handler, then you actually have this account creation, then you actually trigger the account deploy because you are trying to do a real transaction with that contractual smart account. So that's happening. Then if you look at here, we start to execute some other operations on the newly deployed smart account. The first thing we do is, hey, we just swap from the old implementation to the new implementation. So the old implementation is a bi-column implementation. So if we click on that, you can probably tell that a little bit. So there's some information here. So this is a smart account implementation from bi-column, right? Then now we switch. So this is going to be the new, new implementation. And this new implementation will be a so-called modular account. So that's the one coming from, Alchemy, right? So from that event, we can tell we swap the implementation from another, to a new one, right? Now, if you look at here, they continuously have some new events. For example, for the new smart account, we set up the owner. In this case, we keep the same owner, but we have the possibility to add owners or remove owners. Since it's a new account, we only add owners, right? So we don't remove any owners. Then it also shows some internals of the Alchemy modular account because we install this multi owner plugin. So the multi-owner plugin is brought into the picture and participate in this user operations. So the plugin get initialized. Then of course the modular account get initialized as well, right? So those are the internal transactions happening behind the curtain, and we will correlate that to the initialization, encoded function calls, right? Then toward the end, we are doing two ERC20 transfer using the new implementation from Alchemy. So the first one is we transfer from this smart contract to this EOA contract, and secondly, we create this as well. Then of course, like there's some pre-master coming into the picture to pay the gas. Then we also have this user operation events to tell us, hey, now you finished this user operation successfully, and this user operation performs multi-stat that not only just swap the implementation from one vendor to another one, and also initialize the smart contract with a new state. Then we perform two consecutive ERC20 transactions in the same user operation. So this is an interesting trick. We can get multiple transactions happening in the same user operation and to provide that atomic behavior, right? So I think I kind of quickly give you guys a quick walkthrough, like say, hey, if you already have existing smart car, and if you either have to upgrade from version 1 to version 2, or you even completely switch from one implementation to another implementation, which with a very different architecture, the flexibility of this proxy pattern make it possible to make that advanced move, right? So I hope this is something useful, like for you to understand how smart car works and what kind of flexibility it brings to the table. And now we switch to a new modular design. And of course, that will give you more flexibility because the plugins can be built by yourself to enhance the functionality of the smart car. And today we also publish a blog from Alchemy because we are working closely with them to do this migration and adopt the ERC 6900 for our user base. So they put together a very nice blog talking about how you can become a developer to extend the capability of your smart car. So that boils down to writing a ERC 6900 plugin. So this blog gives you a complete walkthrough to tell you what the plugin can do. So think about the plugin as a bunch of like a middleware to your smart car. Then depends on the different passes, the plugins will be invoked by the smart contract to do something meaningful to coordinate the different functionality behind the smart contract. Then you can be really creative and kind of creating different plugins to do interesting things to help validate the user operation and extend the user operation altogether, right? So this kind of give you a walkthrough about everything you have to do and what's happening behind the scenes and what's a handshake between the plugin and the smart contract. So I think this is something interesting if you want to go deeper into that space as well. All right. That being said, I think I kind of finished all the material I have today. But since this seems to be an advanced topic, and I want to keep the door open to see if there's any questions from the audience.
Yeah, if anyone has any questions, please feel free to drop them in the chat. We'll be checking on those. I was also wondering, Raymond, if we can drop a link to that blog that you were just showing in the chat, just in case
Oh,
that
sure. Yeah.
anyone would like to review it.
And that's a good idea. And they copy paste into the chat here.
That'd be very helpful. Thank you. Also, we do have a POAP, but we want to keep that space in case that there's any questions. And thank you so much, Raymond. I think this is super interesting. And at least in my case, and if you're like me, if you're not technical like me, um, I still find this very, very interesting. And we've been talking about smart accounts much more often now. So it does help a lot to have these sessions. And I would personally like to request some more sessions, even about smart accounts and how they work generally. Because it does take me a couple of sessions to get to understand better. So yeah, thank you, Raymond. That's one personal request from me. Maybe anyone else has the same feeling about it. But yeah, I do appreciate this and your presentations. So kudos to Raymond and thank you so much for presenting. And I think that we can get to the POAP now.
Cool. Yeah.
Yeah.
To me, like I think that's a great suggestion because this one is a little bit more advanced because I assume
Mhm,
some of you might have to be equipped with the understanding of the smart contract. But TLDR, smart contract just a smart contract that manages your account and give you that contract address as your wallet address. But behind the scene, there's some code that meaningfully handle the transactions for you. And that's why this modular plugin architecture will be helpful because nobody can predict what function you want to do with your smart contract. So that's why
mhm,
the modular design, the ERC 6900, make it possible for your smart contract logic to be extended with different kind of plugins. And one analogy you can think about is like your EOA. It's kind of like your identity, your social security number, right?
mhm,
Then when you go to different banks, so these banks are kind of like the different blockchain networks. So you can open an account with Citibank, you can open an account with Bank of America or Wells Fargo. Then each of the bank have some program, some software behind each of the account to manage the different functionality of that account. So, for example, of course, it maintain the balance, and then you can deposit into that account. You can use that account to pay somebody else. Then, of course, the account could be attached to other interesting things, like say you get interest, you get reward points, you get referrals. You can use that to you know, uh, for online payment. So this different functionality, just think about the different plugins that the bank develops over time that attach to your account, right? So the ERC 6900 plugin, it's kind of functioning in that way, but it's not being controlled by a single party. It's a smart contract. Every single plugin is a smart contract deployed to the blockchain, and that smart contract is your assistant. It's your extend arms, which helps your smart account to manage a lot of different functionalities.
mhm. I appreciate that summary. Yeah, it is very interesting. And I guess I'm not very familiar with it. Like I've just started using it very recently. So yeah, it is very interesting to me to know how it works and how it's so different to what I'm used to.
Cool. So
Thank
I guess,
you, Ray.
yeah, I don't see any questions from the chat. Maybe it's time to have the pod.
Yeah, let's do it. For you guys in the audience, if you'd like to claim today's POAP, we're using the POAP mini app, so that's with the slash command slash POAP claim. And today's claim phrase is upgrade. All lowercase with no spaces in between. Just that one word, upgrade. UPGRADE. Thank you, the Android. You can also go to the stage chat right now and click the command that the Android just sent. That should allow you to use the Bob claim command. You just need to enter the claim phrase upgrade, all lowercase and with no spaces anywhere. Once you write it down, hit enter and you should receive a code to claim your POAP. Please let us know if it's working for you. Otherwise, also let me know and I can get you a code for you to claim the BOA. Let's give it 1 minute just in case that there's any issues. And again, the secret phrase is upgrade. Okay, seems to be working just fine. So with that, I think that we are ready to wrap things up. Thank you very, very much, Raymond, for this presentation and everyone for attending. I say successfully claimed POAPs in the chat. So I appreciate you guys claiming, and we will see you guys next time. Appreciate you all very much. Thank you, thank you. Oh, before we go, I would like to extend an invitation to our Twitter spaces tomorrow. They will be earlier than usual. So just to give that heads up, this one will happen at 9:30 a.m. Eastern in our Collab.Land Twitter. So let's see if I can share a Discord event invite for you guys to have the link to it and to be notified when it gets started. There we go. This one will be live from it Denver. So if, like me, you're not attending, this will be an interesting one and we'll be able to know what's happening over there. And that there's a ton of events and things going on, so I think it'll be an interesting one. Hope to see you guys in
Yeah.
there, and thanks again for joining.
Yeah. Again, thank you for attending and see you next time.
See you all next time, indeed. Have a wonderful day. Bye bye.